All right, we're going to go ahead and move into 4-8, part 2. We're going to review some things we learned in part 1 quickly, but then we're really going to focus in on the new items. Part 1, problem 1. So we're diving into our complex numbers. We have some more imaginary stuff going on. Problem 1, simplifying a number using I. How do you write the square root of -18? By using the imaginary unit I. So the first thing, remember that negative inside means that we will have an I. We're saying it's the imaginary root of 18. We're going to go to our list and figure out what goes into 18. You would eventually find out that it's 9 times 2. So when you take the square root of 9, you get 3i square root of 2 because the square root of 9 is 3. Now the next thing we're going to do is talk about, and we've already talked about the intro to complex numbers, how you have a real and an imaginary part. We're going to jump into the graph. There are different coordinates just than x and y. You guys have never been introduced to them until now. There are coordinates where we talk about the real axis and the imaginary axis. It's very similar to what you think of as the x and the y axis. Now, as we move along, if I ever ask for the absolute value of an imaginary number, you take the a term, whatever the coefficient is, and you square it. You take the b value, whatever the coefficient is, and you square it. You add them together, you square root them, and that will give you the length of the diagonal that is created by that complex number. Let's go ahead and take a look. So we're going to say what is the graph and the absolute value of the number. We have -5 for the real and 3i for the imaginary. As we go to an XY chart, this is our real axis, imaginary axis. 1, 2, 3, 4, 5 to the left for our real axis. 1, 2, 3. And I'm going to get rid of that dot so you don't think it's a point. I just was trying to indicate I was going to 5. 3 up. So our plot would be right here. That is the graph of that imaginary complex number. Now, if I ever asked for the absolute value of it, it's really asking what is the length from the origin to that. Some people always include the line. You should not. It's just saying what is the length of the origin to it. So you'd get a square root ready. You square the 5. We know 5 squared is 25, and a negative squared is a positive. And then you add the square of the 3, so 9. So we square the 5, we square the 3. We take the square root to get 33, and that's the end. There's no perfect square that goes into 33. Let's do the next one, very similar. We're going to practice 3 of these. This time notice that there is no real number. So what that means is that it was technically 0 plus 6i. So on my real axis, I go to 0. And on my imaginary axis, I go up 6. That is the graph itself, the absolute value of it. And again, if you want to put that 0 in there, because it just looks better to you, you like seeing that extra real number, you may. We do the square root of the 0 squared, which is 0, and then the square plus the 6 squared. We add those up. 0 plus 36, take the square root. So the absolute value is 6. Let's try that one more time. Get your real axis and your imaginary axis ready. We're going to go 3 on the real axis, -9 on the imaginary axis. That dot is the graph. If something ever asks you, just like this one does, it says, what's the absolute value? What we're going to do is say the absolute value is the square root of the 3 squared, add the 9 squared, so you end up getting the square root of 90. Please don't stop there because this one does have a perfect square that goes into it. If you go through your list, you would eventually get to 9 times 10. Now the reason I choose 9 times 10, and maybe you guys like seeing 2 separate square roots for that, like it's the square root of 9 times the square root of 10, because the square root of 9 is 3 and the square root of 10 comes behind it. So the absolute value, just to emphasize one more time, the absolute value describes the length from the origin to the plot. Sorry about that. Now this is review. What is the product? We will distribute like this. So we get 3 times negative 5 is negative 15i. There's not a lot of explanation on this because we did this in the previous video. 3 times positive 2 is 6 and then I squared. Remember, I squared means change my sign because technically it's a negative 1. I'll play this one out in its entirety like this. I squared is a negative 1. So that changes to negative 15i minus 6. That's perfectly fine, but when you look things up, you're probably going to see the real number written first. So we'll distribute again. This time we have 4 things to do. So we get a negative 4 on our first arc. We get a minus 8i on our second arc, a minus 3i on our third arc, and a minus 6i squared on the fourth arc. I will go ahead and make my negative 8i and negative 3i into 11i. I will change my I squared to a negative 1. You may skip that step and jump straight to this step if you're feeling more comfortable with it, because remember I squared is a negative 1. It's simply going to change your sign in the steps coming. So now I can put negative 4 and 6 together, and I end with 2 minus 11i, which now that we've done this, we could technically plot and find the absolute value. One more. This is just one thing to multiply, a monomial times a monomial. 21i squared. Please remember I squared is a negative 1, and 21 times negative 1 is negative 21. Let's talk about dividing. This again is review. I have one of each special type in here. This one has a monomial on the bottom. And what I mean by that is that it has 3i on the bottom. This one has a binomial on the bottom, 1 minus 4i. So they are going to be handled differently. I'm just going to color over that question mark with some white. Let's talk about kind of simultaneous what we'll multiply by. For this one, to get rid of, remember, I is technically the square root of negative 1. You cannot have a square root in the denominator. So to eliminate it, when it's a monomial, you're just going to multiply by I over I. Let's take care of the numerator first. That's going to be 9i plus 12i squared. I am going to continue working out the numerator. Please remember that's really a positive 12 times a negative 1, so it's really just a negative 12. So on the top I have 9i minus 12. And let's do the denominator. I'll change colors just to emphasize. 3i squared. Please remember I squared is simply a negative 1, so the denominator is a negative 3. Check your triangle of numbers that I'm highlighting. Do they all have a common factor? Yes, they do. We must divide by negative 3. We're going to get rid of the negative in the denominator, and everything divides by 3. So if I divide negative 9, or excuse me, if I divide 9 by negative 3, I get negative 3i. If I divide negative 12 by negative 3, I get positive 4 over technically a positive 1, which hopefully you guys remember when we write something over a positive 1, it's not really needed. So there's our solution. Again, you could write it with 4 minus 3i if you rather write it in a different order. Excuse me. Binomial. So in the binomial, we can't just multiply by I over I. We're going to do a little bit differently. We have to multiply by its conjugates. 1 plus 4i, 1 plus 4i. I'll deal with the top first. Let me draw a nice straight fraction bar. All right. Grab some parentheses to indicate my binomials. 1. So 2 times 1 is 2. The next one. 2 times 4i is 8i. The third one, and change colors because it's getting kind of weird here. That green arc is positive 3i. That green arc is positive 12i squared. I'm still going to just continue to clean up the numerator. All right, so let's see. I can definitely put my 8i and my 3i together. That makes 11i. I know this is really 12 times negative 1, which is really negative 12. So I can put my 2 with my negative 12 and get a minus 10. Put my 2 with my negative 12 to get a negative 10. That red did not look good over that orange. Denominator. 1 times 1, 1 times 4i, negative, I'm going to change color because it's getting kind of confusing, negative 4i times 1, and negative 4 times 4i is negative 16i squared. This is really just negative 16 times negative 1, which is really positive 16. Boink, boink. Now I'm going to combine my like terms. So I have a 1 and a 16, which makes 17, and the 4 i's cancel. So let's take a look at what we have left. So we're going to look at this stuff right here. I kind of put in that blue shape. I end up with, I'm going to put it in order if you don't mind, a negative 10, a positive 11i, and a 17. If I look at the triangle of numbers, 1, 2, 3, they do not all have a common factor, so I am not going to reduce them. I'm done. Okay. Let's take a look at problem 5. What is the factored form? Now, I think I should probably bring you back to something we talked about in 4.4, the difference of perfect squares. This is old. This is the difference of perfect squares. It quickly factors to x plus and x minus its square root. So I could do that one more time as a means of review. If I had 4x squared minus 16, let's do minus 49. That's the difference of perfect squares. I could factor that into its square roots, 2x plus 7, 2x minus 7. So there's shortcuts to take when it's the difference of perfect squares. Guess what? There's also shortcuts to take when it's the sum of perfect squares. So you should notice that this is not a perfect square. So if the question asks you to factor it, which we do, the first thing we should do is take out a GCF. We should always be looking for a GCF. In this case, it's a 2. Now, if we wanted to, we could see this is the sum of perfect squares. The sum of perfect squares will be very, very similar to the difference of perfect squares. You still take the square root of x squared. You still take the square root of 16. You still do 1 as a plus and 1 as a minus. However, let me move that forward just a little bit. You must put an imaginary label on the second numbers. Now you might say, how come? Why is that? Well, let me show you. So number 1, this is the factored form. They asked what the factored form is. There it is. Number 2, here's the proof. If I do, I'll leave that 2 there just for a second. If I take my answer that I just had and I distribute it together, I get x squared minus 4ix plus 4ix minus 16i squared. I'm going to pause because I did that really fast. You'll notice the 4ix's cancel, and you're left with x squared minus 16i squared, which is really x squared minus 16 times negative 1, which is really x squared plus 16. And if we drop down that 2 and put that 2 in there, you would absolutely get the original form. So the only way to factor the sum of perfect squares is to use imaginaries. Again, this is the answer. Everything underneath was the proof. We're going to do that again. GCF of this binomial, 5. Take it out. And when I say take it out, it's like factor it out, divide it out. And now I see the sum. Oh, I didn't divide very good, did I? That should be x squared plus 4. I see the sum of perfect squares. Those are perfect squares. So I bring down my 5, take the square root of x squared. One's a plus, one's a minus. The square root of 4 is 2. I and I. And if you would like to distribute that through like I did in the previous one, you may. 4 more problems. I am hoping for 10 more minutes. I'm going to suggest that you pause the video, come on back, And then let's just get the rest done because I think probably it's been long enough. Take a break. Maybe go get some water. Come on back and we'll do these. All right, I hope you took that break. Now, the first problem we are going to solve. Now, little do you know that this just looks like a normal thing to you. It should look like a normal quadratic, like, okay, I'm going to do the quadratic formula, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a, no different than what we had previously. Now, as you plug things in, b, b, a, c, a, and as you reduce, notice we get a negative in the square root. That's why this is now different. That's why I can include these problems. You take the negative out and make sure you label it as an imaginary square root, and that's how you finish your answer. So it's almost exactly what we've been doing. It is actually exactly what we've been doing, but now we're going to get a negative inside our square root, and now we know how to deal with it. We used to just be like, no real, and stop. But now we can actually say, hey, I have an answer. It just so happens it's an imaginary answer. So step one with the quadratic formula, set it equal to 0. A is 3, B is -1, C is 2. And may I encourage you to pause the video and try this on your own. Opposite B or negative B plus or minus square root of B squared minus 4AC all over 2A. We're going to put this part in our calculator without the square root. And I know 2 times 3 is 6. Watch my calculator. Notice I do not put the square root button. I'm going to hit enter. So I have everything that was on my problem in my calculator. -23 is what I get. I'm going to go ahead and take that I out because I see it's a negative. You can put it in the front or the back. I tend to just put it in the front. That's how I leave my answers. I mean, if you want to, you can separate it like this and put like the square root of 23 over 6 and put the I behind it. That's totally fine. I'm good with whatever. But what I do want to let you know is I did check. There's no perfect squares inside of 23. So I didn't like try to break it apart. I think there is one on here though that we will. Okay, let's try again. Oh, not equal to 0. We got to get that equal to 0. Okay, A is 1, B is -4, C is 5. I did that fast, so I'm going to let you catch up. And now I'm going to do our little formula. Opposite B plus and minus the square root of B squared minus 4AC all over 2A. Please again, notice that I am using parentheses around B squared. If you don't use parentheses on these type of problems, there's a good chance you're going to get it wrong. I'm going to change my highlighter color because it's a little obnoxious. I'm going to put that in the calculator without the square root. So I'm going to have 4 plus and minus the square root of something over 2. Let's go ahead and see what that something is. I'm going to hit enter. -4. Well, this is going to be a very interesting problem. Let's start by taking out the I. Now, hopefully you guys are noticing like, ooh, the square root of 4 is a perfect 2. Yes, it is, with absolutely no leftovers. So I'm going to go ahead and change that to a 2i over 2. Notice the square root is totally gone when it's perfect. Look at your triangle numbers. They all divide by 2. Greatest common factor. So I'm going to do 2 plus or minus 1i over 1. And I think we're probably at a good spot now where we can say we don't need the over 1 or the 1 in front of the I. So final answer. And if you want to write that separately, just in case anybody's wondering, like, how are there two answers? There they are. Okay, so you can write it as plus and minus, or you can write it two separates. All right, one more, everybody, and then we're all done. You're doing real good. At least I hope you are. Make sure you're jotting down any questions that you have so I can answer them. So we're going to distribute, and then we'll get this thing equal to 0. You know what? I did that kind of fast. Hold on. Let me just write equals -5. So distribute the 2x, add the 5 over. I'm going to pause because I feel like I did that really fast. Now I'll identify A, B, and C. Be careful, B is -6. Opposite B, plus and minus the square root of B squared minus 4AC all over 2A. I'm going to put this part without the square root in my calculator. 2 times 2 is 4. Please grab a calculator so you can practice it as well. I mean, you can watch me solve your problems all day, but unless you do them yourself, it's really not going to benefit you just to watch me. So make sure you're getting physically, like you're physically typing these into a calculator so you can make sure that you're also getting, oh, there's a -4. So we actually just saw this in the previous. We're going to change that to I square root of 4. And then we already know that the square root of 4 is 2. The only thing I kind of regret about these notes, oh, hold on. Finish the problem, Amy. Boom, boom, boom. See those three numbers? They all divide by 2. So I can get 3 plus or minus I over 2. I'm very happy with that answer. And that's technically 1I because 2 divided by 2 is 1. I'm also very happy if you want to break it apart like this. Or maybe even 1/2 I. Those are like totally, they're the same and they're both totally fine. I'm perfectly content with both of them. As your teacher, I accept both of them. The only thing I kind of regret about the examples is I don't have one that would have like had the square root of, this is like -40, because then I would be like, okay, pull the I out. And then I would say, okay, what goes into 40? And you would figure out 4 and 10. And then I say, okay, pull that out. And then you could go from there. So again, I kind of regret that none of these problems have that on there. I'm not going to redo the problem. But if it happens, you would just continue through with something like that. And just like we would from yesterday and from 4-7, you take the squares out that you can, and then you go from there. All right. I hope that wasn't too fast. Let me know if you have any questions.